Today we're starting our final unit, and this is called Other Nonlinear Functions. So you'll see some things that look like smooth curves, but then we'll introduce some new functions to you. Today's topic is called square root functions, and you can use the date of May 27th. We only have about 15 student attendance days left, and we have about 9 or 10 lessons, so we're almost done. Your note packet has 5 pages. These are the first 3 and the last 2. We've been working with inverse functions throughout the course. If you want to get rid of a constant and you're adding 3, we would subtract 3. The opposite of multiplying by 2 is dividing by 2. We've been using inverse functions all along. We're going to look at squaring versus square rooting. These are also inverse functions. So for our first example, we're going to square x when I tell you that x equals 7. So all we're basically going to do is sub it in. Don't forget your parentheses. So 7 raised to the second power is really 7 times 7, and that gives us 49. For our second example, we're going to find the square root of x when x equals 81. We've been working with square roots all along since the beginning of the course. We're going to sub in 81. Keep in mind that there's both a positive and a negative root, so when I come up with an answer, it's both positive and negative 9. And our third example, when you square and square root, because they're opposite or inverse functions, basically they cancel each other out, and the value that we have here is just 17. So you don't even have to go through the squaring and the square rooting. Just that simple knowledge, you can put down an answer. We also have inverse functions when it comes to graphing. So our parent function for a quadratic equation is a parabola. We can see that it's an incomplete quadratic. There's no linear or constant term. And the turning point is at 0, 0. And half of it's on the left side of the y-axis and half of it's on the right. But there's also an inverse function for the quadratic equation. So to calculate what it is, we're going to start with our parent function of y equals x squared. And when we find the inverse function, we switch the position of x and y. So we're going to do that now. So now we have x equals y squared. The goal is to get y alone, and that will provide the inverse function. So to get y alone, we're going to square root y squared, but what we do to one side, we have to do to the other. So the square root of y squared will be y, and now I have the square root of x. So this is the inverse function to a quadratic equation, and this is also graphable. So you can see in my picture, the green is our parent function for a quadratic equation. The blue is the parent function for the inverse. You can see there's a positive square root of x and a negative square root of x. When you examine both pieces, this will fail the vertical line test. So if you were trying to use a pencil or any vertical line anywhere along that blue function, it would hit it in 2 spots and it would fail. So what we do for the parent function for a square root, we only acknowledge the principal square root, which is the positive square root of x. And we don't acknowledge the negative. So this is what the typical parent function looks like for a square root function. Notice it starts at the origin, and it passes through 1, 1, and we have 4, 2, and if you continue on, you can see it will hit in more spaces. The value of x cannot be negative. Remember, we've talked about that before. Right now, with our knowledge, the square root of a negative number doesn't exist. So we're going to graph some of these today. If you'll take a minute and graph this on your iPad, you'll want to activate the square root function first and then go ahead and type in x minus 4. And remember, you can pause the video if you want to do that before I go on. You'll also want to look at the split screen table. You'll notice that some of these values are listed as undefined. They're not graphable. What that tells me is the value underneath the square root function is negative in those positions, and that doesn't exist for us. But starting at 4 and 5, we have exact locations, and then at 8, 2, and 13, 3. So even though the table generates an infinite number of x and y values, we're only going to graph those that are good looking. So we would plot 4, 0, 5, 1, 8, 2, and 13, 3. And we do want to make sure that we put an arrow on that end as it approaches positive infinity. Now this is what my iPad displayed. And don't forget, when you graph it, you do want to put your label. Now that it's graphed, we can identify the domain. Remember, the domain travels along the x-axis and it represents the x values that are possible in your function. The graph does begin at 4, so we use the bracket to include 4, and then as we move further to the right, we can see that our graph will approach positive infinity. The range, if you start down low and work your way up, we don't start the graph until we hit 0. So we're going to start with 0, and again, we're going to use a bracket to include 0 as part of the function. But then as we move up, this graph will continue to get taller and taller, so we're approaching positive infinity. How does this graph compare to the parent function? Well, we know the parent function starts at 0, 0. We're still located on the x-axis, but basically we have slid the function over 4 units to the right. Notice how this was a change from the parent, -4. This is inside the function. So we're going to say we move the graph 4 units right. In example 2, if you'll take a minute, start a new graph. When you activate the square root function and put the x inside, make sure you use the arrow to move you to the right before you hit -4. We want -4 to be underneath, outside that square root function. We don't want it to be underneath. So we're going to look at the graph and the table. Again, there are certain values that will be undefined. Graphing cannot occur there, but we can start our graphing at 0, -4, 1, -3, and then 4, -2, and 9, -1. So let's see how this looks. So we're going to plot those 4 points. You'll typically get that classic structure of a square root function, even with 3 to 4 points. Once you have an idea of how it looks, you can just kind of sketch it out. So now we're going to identify the domain. So as I'm moving from left to right along the x-axis, I don't even hit the graph until I hit x equals 0. So we're going to begin our domain at 0 and include it. And again, we can keep moving to the right and we're approaching positive infinity. The range, if you start down below and you move up, we do hit the graph finally here at -4. So we'll begin our range at -4, but the graph itself keeps opening up and goes out. So we're approaching negative or positive infinity as we go up. How does this graph compare to our parent function? It's still typically the same, but we can tell that it went from 0, 0 and it's been moved down 4 units. Notice the -4 is outside that square root function. That's our movement up and down. So we can simply say the function moved 4 units down. In example 3, we're making our square root function a little bit bigger. We've got an extra value underneath the radical, and then we have an extra value outside. So if you want to take a minute and put this into your iPad and generate a table and a graph. On the graph, I'm still getting that general function shape, but it's not starting at 0, 0. So in the table, you can see these are the 4 points that we're going to graph to get that basic shape. And we want to label our function right on the graph and put an arrow over here on the far right. So underneath the function is our movement left and right. Remember, x lies to you, so it's going 1 unit right. And then outside the function is our movement up and down. But this doesn't lie to you, so this would be a movement of 2 units up. So our domain, starting over here on the far left, we're traveling and we don't hit the graph until x equals 1. So again, we're starting with 1. We're using a bracket to include 1 as a solution, but we're approaching positive infinity. On the y-axis, as I travel up, I don't even hit the graph until I get to positive 2. So our range will start with positive 2 and include it. And again, it's still going to move up, so the graph is approaching positive infinity. We talked about how the graph compares a little bit when we examine the function. So this graph is going to move 1 unit right and 2 units up. So there's 2 movements instead of 1. In our final graph, if you'll take a minute and put this into the iPad, you'll notice there's a negative outside the square root radical. This is okay. It just can't be negative underneath the radical. So when you enter this into your iPad, this is the table that's generated. These are the 4 values that we're going to plot to graph our function. And this one looks a little bit different. It's upside down. And that's what the negative is doing outside the square root function. So the domain, starting over here on the far left, as we travel along the x-axis, we don't hit the graph until we hit positive 4. But you'll notice even though it's underneath the x-axis, it's still positive and it's heading towards positive infinity. So the domain is from 4 to infinity. The range, even though I would hit it, we're starting from underneath. This is really negative infinity down here, and the graph stops right on the x-axis. So this one's a little bit different. We're starting from negative infinity. We're approaching 0, but we actually stop the graph at 0, and we include it. So how is this function different from the parent? First of all, we can see that it's moved over 4 units to the right. But we also know that it's underneath. So if you remember from previous lessons, we have taken the function and we have reflected it over the x-axis. So my description has both movement 4 units right and a reflection over the x-axis. This will be homework number 121. This is the number that's going to be correct now. There'll be 8 problems. Make sure you follow the instructions. You're going to sketch a graph, include a table of values. You're going to identify domain and range, and then tell me how it's different from the parent. If you have any questions as you go through this assignment, please don't be afraid to ask me. Have a great day.